वाली स्ट्रीम डिलीट कर दूं?
अरे हो जाएगा, हो जाएगा। मैं माइक म्यूट कर दी।
ऑडियो कनेक्टेड है क्या?
मैं माइक
Okay, so guys, hello. Yeah, so we're beginning with the first problem. Like this one is quite easy. You could just see it's based on the trivial inequality of x squared greater than equals to 0. So using that fact, you can just say a plus b minus a plus b minus 5 and the rest of the other two terms, that all the three terms are going to be 0. So yeah, just write those three terms. Yeah, so I'm back. The voice has got disconnected. So yeah, so it's based on the trivial inequality. That is, the squares has always to be positive because in reals we are considering the squares to be positive since it was given in the problem that A, B, C are reals. So you could just use the fact and then just like you could bash or just gain the answer.
Hi guys, so just the second question of KV IOQM. So I think it's a very easy question. So we have something called the British flag term. Let this be P. So I'm just not digging deep into it. I'm just directly using the formula. So yeah, you can just Google this. and we're done. So yeah, it's a very easy question, I suppose.
Okay guys, so this was one of the geometry problems in the 2 markers. So this is based on the tangent, distance of tangent that is touching the circle, and a bit of Pythagoras theorem. So you could just make the diagram and mm, just measure the length. So yeah, just let me import the diagram so that I could write on that. Yeah, the diagram is imported. So yeah, just measure the length. Like this is given that this is the point A, this is B, and this is C. So it's given that AI, since it's an equilateral triangle, so the thing here should be 90 degree. That is the angle angle ADB. So there's an extra point D. So it's given that AI is 3 and the distance from I to BC is 2. That means the radius given is 2. And then you could just make this length would be also 2. And then you can actually get this length, which would be root 5. So basically what you do is x square plus 4 equals to 9. So you get the length of AE. Suppose that this is the point E or actually AF. So let this point be F and let this point be E. So you get AF equals to AE, which would be root 5. And then you can suppose this length to be X. So FB equals to X. And then you can apply the Pythagoras theorem to get uh, AD square plus X square equals to root 5 plus X square. So you could just bash from there the value of x, and then you could just square, and then you could just get 2x and then square it to get the value of BC. So that's all in this problem. Okay, so problem 5 is based on the Legenders symbol or the Legender symbol. That is the n factorial by p to the power k thing. This is like actually easy. You just need to go and bash this problem. There's there's nothing in this problem. So yeah, you could just go on checking the powers, which would come to be, so at the 56 you get to the power 9 because you get 56 by 7, that is 8, and once again you divide it by 49, so you get to the power 9, 7 to the power 9. So actually all the numbers from 49 till 55 are the values of n. So you get total 7 values of n. That is 49, 50, 51, 52, 53, and 55. So these are all the 7 values which would have the highest power of 7 as 8. So answer for problem 5 is 7.
For this problem, we have to first construct the problem. So it's ABCD, it's a square. Let me make it. This is ABCD with side length 100. We have given this a circle with center C. This is the center and radius CD. So this is the radius. The circle is like this. Is drawn to touch. Oh, sorry. It will pass through B. It will be like this. Another circle of radius r lying inside ABCD is drawn to touch this circle externally such that the circle has also touches AB and CD. AB and CD. So AB and AD, sorry. It will be like this circle. So this is our diagram. So we have to solve for the radius of this circle r. First of all, we will make this r like this. This length will be r root 2, and this we know this is 100, and this is r. So we will add all those. R root 2 plus r plus 100 equals 100 root 2, which is the diagonal of the square. So it will be r root 2 plus 1 equals 100 common root 2 minus 1 r. It will be root 2 minus 1 here, and root 2 plus 1 will go down here. So we will simplify this and we will get the answer.
Problem 8 was based on modular arithmetic. That is, like you just need to find first the unit digit, which goes on like which has the unit digit as repeating. That is, if you square, you get that value, and if you cube also, you get that value, and that goes on till like whatever you raise the power to. So what you see is that you have a special number that is 6. So you square, cube, or whatever power you do. So you always get uh, to the power 6. Like 6 to the power 2 is 36. 6 to the power 3 is 216. So yeah, 6 to the power n is congruent to 6 modulo 10. And you got the unit digit of the number. So now what you can do is just bash the case of tens digit. So this shouldn't be any problem here because you could just square and check the values. And if you have done some problems like extensive problems, so this was a problem very similar in the intermediate algebra book of EOPS. So the answer here of n is 76. So I would say this was a copied problem from the AOPS or the AHSME exam or the AMC exam. This problem actually came in one of the exams. So the answer is 76 for this one. Yeah. So this was all for the problem 8. And we'll actually move to problem 3 and would just come back to the left problems. So don't worry for that.
So this question was just weird abash, and this was also copied, I would say. I think USM 1970 or something like that. And it's a very famous problem. Just consider x, y, z be the roots of an equation, or just normal bash it. So let's bash.
Actually, there's a typo in the problem. So yeah, it should be
Yeah,
x squared plus y squared plus z squared. So
yeah,
maybe you could just edit that or like edit with a pen here. Like this one is just supposing the roots and then just
yeah. Just Newton sums or something like that.
yeah.
So so wait a minute. Yeah, so let's bash.
Yeah, you could do one thing that since the problem has x, so making a cubic in x won't be good. So you can make a cubic in t, or like t cube plus a t square.
X is a variable, so it is. We should not use X in this.
Yes, sorry.
Yeah, yeah.
So it's 10, right? If I'm not wrong. It's 10. So this is the equation we've got, and by Newton's terms we can conclude that an is actually just so we know a1 is 7, then a2 is 27, I guess, and similarly we can find a3. So yeah, just bash like that, bash, and we will get, I think, wait a second. We have two solutions, right? So yeah, that's it. This also looks a copy problem to me from AIMS post, I think
This also
2006.
looks a copy problem to me from AIMS course, I think 2000.
So yeah, I remember it doing it in the mocks. Most probably it was 2016. I'm not sure.
Yeah, so can you import the problem 17? Yeah, problem 17.
I've uploaded the problem 17 on page 4.
Okay, thanks.
Let me upload again. Uploaded on page 17.
Okay, thanks. So problem 17 is also based on geometry problem, like it's of angle chasing. Yeah, just make a regular polygon, and also you don't need the whole regular polygon. You just need to find the value of n. So if you get the exterior angle, so you could divide that by 360, and you could actually get the value of the the number of sides in the polygon. So it's given that when the two sides of the polygon are extended. So yeah, I'm just extending it. Actually, if someone of you could extend the lines, because the thing is not working for me.
I'll extend it from where should I extend it from? Tell me. I'll extend it
Yeah, just extend any two sides,
like this.
and the left one also.
Yeah, like this.
Yeah. Thanks. And so that makes an angle of 28 degrees. So yeah, that angle is 28 degree. So you have this as a regular polygon. So the thing is that the two side lengths would be equal. So it would be an isosceles triangle. So you could make 2x plus 28 would be 180 degree, where x is the exterior angle of the polygon. Yeah, so 2x plus 28 equals to 180 degree. So yeah, just do the calculation. One, yeah, and then 76. So you could divide by.
So we have a counting problem here, probability but count. So we have a circle. So I think I can just fill up the gaps. Just jet. I just draw 8 marbles here and then I'll just put the other 4 in the gaps. And obviously the same colored marbles are identical, so it makes our work easier.
You have drawn more than four, I guess. Green marbles.
I believe just
Okay.
did I make any mistake like overcoming or something?
No. Fine.
So yeah, what's this P by Q? IDK. Oh, so I have to calculate it now. My God. So what's 8's choose for? Have you marked up the value or something? No, it's wrong. It's for sure wrong. I made a mistake here. Like, uh, I don't want to calculate this, so yeah, you can just calculate this one. You will get p by q plus q equals 40, I think. Yeah, you should get 40. I think I have not made any mistakes here. The picture is very blurred, you can just replace another pic with it. This is just cosine bash.
No, there's a like. Are you
I
talking
don't know
about
the
problem?
elegant solution of something.
It's an classical problem. Let me draw the diagram.
Yeah, but
Guys,
no, I was talking about studying. Like,
can you
let's see
close
what
Similar
the?
triangle. We can do with similar triangles.
no, I'm talking about P13.
Oh, sorry.
First of all, close the YouTube in the back end. It's like making very noisy.
Yeah.
So yeah,
Is the,
P13. I
is
think
the
it's
diagram right?
I
Is the
don't know
diagram right?
other elegant solution or something.
Which problem are you talking about? Like problem 13 is cosine
14.
dash, and there's
Problem
a
problem
the,
14. 14.
Okay,
14.
we are 14, right? But
Yeah.
let's do
yes,
13 first.
yeah.
Okay.
Let's do 13 first because it's easy.
Okay. Okay. Let's do 13 first. Then. Let
Yeah.
me
So
do it.
will you make a triangle for problem 13?
I'm making it. Wait.
Yeah.
We
So
don't need a diagram to be honest.
yeah, just make the first of all make the angle 60 degree. There's a special trick associated with this problem, like uh, there's a property in geometry that the that whichever side has the maximum angle has the maximum side length opposite to it. So
Yeah. So which angle should I make 60 degree?
yeah, just make anything at 60 degree and then we could just erase and try it again.
Okay. So let's make the at angle between x and x plus 2 60 degree first, and
Like it's
let's
like
Just
it's obvious
yeah,
that
just mark it as
60 is the
ABC.
second largest angle, right?
Just
yeah, yeah.
mark things as ABC.
Okay, okay. Let me. So we have to solve from this low. So we have to apply cosine here, na?
No,
Yeah,
wait.
cosine batch, nothing else.
No, there's a special trick associated with it. Like you can't just bash directly because you won't get the value of x directly. And there's this reason why that won't happen because you see you have 60 degree. So the other two angles sum up to 120 degree. And we see this is not an equilateral triangle. So the other has to be, one has to be greater than 60 degree and one has to
Yeah,
be
yeah,
less than 60 degree. So
yeah,
what you see is that if you suppose any of the angle as less than 60 degree, so it has the opposite side as x. So just mark the angle x, angle C as
A will
theta.
definitely not be 60 degree, na?
A will be 60 degree. Just mark that. Just mark C as theta or something like that. Whatever variable you want to consider.
Theta c. Let me mark it theta c.
Okay, yeah. And then you could just get B as theta B, which would be 120 minus theta C. So angle B is greater than 60 degree. So it has the maximum side length opposite to it, which would
Yeah,
be 2x plus 1. So you could just replace 2x plus 1 with x plus 2. Those two side lengths would be replaced. And from here, you can just apply cosine rule.
yeah, yeah.
So this was a trick associated with it.
AC would be 2x plus 1, na?
Yeah, basically
Yeah,
that was on.
Yeah,
I was talking about that itself, right?
yeah.
Uh, it's
So
obvious that 60 is the second largest angle, right?
yes,
yeah, 60 would be the second largest angle,
Yeah,
and
then it's
could
all done. Then it's cosine batch, nothing else.
yeah rule, and then you would get the value of x eventually to be 3 by 2, and then you could add 4x plus 3, and then just put
let
the
me do the
value of
calculation. Wait, let me do the calculation here. Or
That's
yeah,
the
yeah,
easy
yeah.
part.
yeah, it's just calculation, no?
Lol, I was thinking that cos 60 equals to 3 by 2.
So since x can't be equal to minus 1, so it has to be 3 by 2. So therefore the value of x is 3 by 2,
Yeah,
and then you
Yeah,
just
done.
need to put this thing. The perimeter is 4x plus 3. This is the perimeter. So you put 3 by 2 in x. So you get the value of perimeter to be 9.
yeah. So answer is 9.
Yeah.
So let's do the 14th question now. Very classical question.
Yeah,
Let
I mean, I really hate this thing that, I mean, so many problems are copied.
Yeah, yeah. So let's do this. Let the side of the square be A. Here BQ will be equal to RC, which will be 10. Sorry, it will be 5 minus A by 2, and here also 5 minus A by 2. Uh, we can apply similarity or what? What should we do now?
First of all, you should make a diagram so that you are able to understand things.
It's
I made
quite
the
a
diagram.
modified version of 2017 PRMO. Like, we had
Yeah,
Hmm.
some
yeah. This one,
triangles in the rectangle, and we have to just, you know,
Yeah,
Pythagoras. So,
we can apply trigonometry from here. Like in the triangle PBQ, we have two sides and we have one angle. So tan 60 is equals A by 5 minus A by 2, which is 3 root 3 by 2 equals 2a by 10 minus a. So 10 root 3 minus root 3a equals 4a. 10 root 3 equals a 4 plus root 3. We can simplify from here. A equals 10 root 3 upon 4 plus root 3. Is it correct?
I suppose that's correct. Or maybe you could just apply similarity. There's no way talking on this problem. Like it's of NSCGS level, and it was like in whichever module you solve, you get this problem in the module in the geometry section.
Yeah, and
Yes.
it's
Yeah, yeah.
P15, literally. I mean P14. 3 marks, 3 marks.
Yeah. So should I solve next or should we do another problem?
Yeah, you can just explain the thought process to us.
Yeah. So you can repeat the equation. I will write here. What was the equation? Yeah. Yeah. So we have to solve this. So what are x and y here? Okay. So what is the solution of this? Okay. So what is x and y here? You have solved it. Okay. Okay. So let's do 11th.
Yeah, could you import problem 11?
It's just
Okay.
one thing I've noticed is that in the recent years, PRM has been involved in many Diophantine equation sort of questions, like those typical AIME problems.
Yeah. So like, which problem are we solving?
16.
Okay. I mean, if you have less time, you could just go on and bash.
Yeah, and I would just go to play badminton now.
Ayush is speaking. Let's wait and listen to him.
Okay, so in this, as some number of power of 2 is represented in two factors, so each factor should be of a form of a power 2. So it be 2 to power m and 2 power n, or it could be minus 2 power m or minus 2 power n, as minus will become plus 1 and it will again give power of 2. So let take first case.
Could you please annotate on the jam?
Now taking 2 to the power n common. Now as these are these numbers are also integers, and 6 can be written as either 2 into 3 or 6 into 1, or for positive integers. So any one of these two pairs exist. If we see 6 into 1, we can see it could neither be in form of 2 to the power n, neither in form of 2 to the power some number minus 1. And if we see 2 into 3, we can see for n is equal to 1, and if
So
this
n is equal to 1 and m is equal to 2. M is equal to, sorry, it would
3.
be 3, 3, yeah, 3.
So for one pair, we come here is
8
m
and
is equal to 3 and n is equal to 1. So here x equals to uh, 12, and y equals to 4. And then solving for case 2, we will get pairs of x is equal to 2 and y is equal to um, 4. So maximum x and y is equal, x plus y is equal to 16.
Yeah, so for problem 11, this was based on the prime numbers. So you need to use the factorization trick by rearrangement of the terms. So you could just move b square to the right hand side, and so then you can factorize. So you get 2c minus b and multiply by 2c plus b equals to a. So what is the trick here? A is a prime number, so 2c minus b can't be negative and it can't have a number like 2, 3, 4, 5, because if it has a number greater than 1, then A can't be prime, because then it would have it would have two factors in it. So then it can't be prime. So 2c minus b has to be has to be 1. And then 2c plus b, you have to check by mod 3, I suppose, because if it take mod 3, it would be easy to check. Yeah, 2c plus b can be 3, 5, 7, 11, 13, 17, 19, and you could add right like right till 19, because then if you have 19, it would be easy to observe things. So you could just add both of them. So you get 4c equals to 4, and then 6, 8, 12, and 14, 18, 20, and then it goes on. So what you get is c equals to 1, which would be obviously rejected, and then c in 8 would be 2, which can be accepted. We have to check this thing. And then you get 3, you get 5. These are the sum values we need to check. So, so what you do is put this thing 2c minus b equals to 1. You put the value of c in this equation. So you get the value of b as, for 2 you get 3, for 3 you get 5, and for 5 you get 9, which would be rejected. So these are two of the values, and then you just need to put it here. So 2c plus b gets satisfied in this thing, that is the 7. Just a moment. Yeah, if someone of you could circle 7 and 11, it would be actually very great. B equals to 13 won't work because you add 1 and it gets 14. So it won't be an integer when you divide by 4. So hope that clears your doubt. Yeah, so so A equals to 7 and 11 also works. So now you could just add the two values. So you get so you could add and check. So the pairs are, yeah, if someone of you could write the pair as 2 7 comma 3 comma 2 and 11 comma 5 comma 3. Yeah, just write the pairs because the thing is not working for me. No, 9 won't be the answer because you have two pairs. So the answer should be 31. Yeah, if you could solve other problems. That is all I have from for this problem. We could actually solve problem 18 because it is also geometry and related to mass points. Yeah, so just move the page to problem 18. Okay, thanks. I can see the problem. So yeah, if someone of you could make the diagram for me. Okay, make the diagram. Yeah, there's a bit of internet issues, so kindly cooperate. Just draw the ratios like PF. It's given that PF upon FC is 2 upon 3 and PE upon PV is 2 upon 7. Yeah, so basically what we can do is we need to find PD upon PA. So what we can do is we have a conjugate like this is a problem of multiple mass. So what you can actually do is take the mass at point P to be 45. And why I took 45 is because the LCM of 5 and 9 is 45. So you could take mass at P to be 45. Just mark the mass at P to be 45. And then, yeah, 45. And the mass at C should be 2 into 9, that is 18. So, no. The mass at P is 45 and the mass at C is 18. Yeah, and the mass at the point F is 27, and the mass at C is 7 times, that is 35. Mass at E is 35 and mass at B is 10. So now this problem becomes easier. So the combined mass at A is 27 plus 35 and the mass at B is 10 plus 18. So mass at B is 28 and mass at A is 35 plus 27. That is 62. Yeah. And then it would be 31 upon 14, which is like 45. So 45 is our answer for this one. I suppose this is right because it is of multiple mass or like split mass, whatever you call. So this was our answer. Actually, there won't be the addition sign. Are we talking about the CVAS theorem? Because you can't apply CVAS on the problem 18.